Okay, so today we are going to be continuing our discussion with volume. What we're going to be doing today is we're going to be doing a little bit of problem solving that involves finding the volume of rectangular prisms and also finding the different shapes of those rectangular prisms that have particular volumes. The first thing to remember is that as we are working through story problems and doing some problem solving, the first step is always to identify our problem. Second is going to be to identify that important information. And then third, we want to make a plan for how we're going to solve it. So here we have Miss Wilton, and she is planning a rectangular flower box for her front window. She wants the flower box to hold exactly 16 cubic feet of soil. How many different flower boxes, all with whole number dimensions and different size base, will hold exactly 16 cubic feet of soil? So as we look at this problem, our problem is down here with the question mark at the end, and it's how many flower boxes will hold exactly 16 cubic feet of soil. And then we have some constraints here, right? Like we know that it's 16 cubic feet. We know that the sides all have whole number dimensions. That means that we can't have things like 1.5, right? Like that's not allowed. And then we have a different size base. Now, when we talk about different size bases for this lesson, what they are really referring to is not only a different size, but a different shape as well. So let's say that our base has an area of 4 square feet, right? It could be a 1 by 4, or it could also be a 2 by 2, right? Like, so these are two different size bases. We would not say that a 4 by 1 is a different than a 1 by 4 because really all we've done there is take a rectangular prism and rotate it around a little bit. So just keep that in mind, right? We're not just reversing the numbers, but if we can come up with different dimensions to equal the same square foot or square units, then that is okay. Right, so we want to look at some potential like flower boxes for Miss Wilton here, and we need to have a volume of 16 cubic feet, right? So when we look at this, one thing that we need to remember is that our formula for volume is length times width times height. And if we were to break this down and think that we need to come up with three numbers that when multiplied together equal 16, it gets to be like pretty overwhelming. So instead of thinking of like this full formula for volume, what I want to do is I want to put together my length and my width, and I want to remember that I can think of this as the base area of my rectangular prism, and that if I multiply that by its height, then that will give me my volume. So when I do it this way, it just makes it a lot simpler to come up with all of the possible solutions. And this is what I'm going to use for most, if not all, of the problems that we look at today. So let's add a page here and let's talk about a nice kind of easy way to take care of this. So I'm going to start off with the number 16, and I am going to list all of the factors of 16. So 1 times 16, 2 times 8, 3 doesn't work, 4 times 4. Remember, when I do this, I'm just basically going in order, listing all of the factors of the number that I am working toward. And then when I get to the point where the two that are out here on the end are either the same, as in this case, or there are no more numbers in between them that would be multiplied together to equal 16, then I've found all of my factors, right? So here we are. We have the factors 1, 2, we only need to list the 4 one time, 8, and 16. So I know that these 5 different numbers can be multiplied together to equal 16. So I'm going to go back to my formula and say that base area times height is going to equal 16, right? So if my height is, let's work from this way back. If my height is 16, right, then my base area has to be 1. If my height is 8, my base area has to be 2, right? And so on and so forth. But this, it doesn't like completely answer the question, right? Like if we went through like all of these, like we would still kind of come up short on our answer. So let's take this 16, let's slide it over here, and let's write out our entire formula, right? So length times width times height. Well, for this first one, right, we already said that our height is set at 16. If our base area is 1, right, what numbers can we multiply together to equal 1? It's pretty simple. We can do 1 times 1, and that's going to equal 16. 1 times 1 times 16 equals 16. So that's one of my flower boxes that I can make. We're going to move on to our second one here. My height again was set at 8. My base area is 2. So what numbers can I multiply together to equal 2? 1 times 2 equals 2, and 2 times 8 equals 16. If my height is 4, right, my base area has to be 4 as well, because 4 times 4 equals 16. So I'm going to come over here to my length, width, height chart, and I'm going to say that my height is set at 4. And what numbers can I multiply together to equal 4? Well, we always can multiply by 1, right? So we get 1 times 4 equals 4. But in addition to 1 times 4 equaling 4, we also know that 2 times 2 will equal 4. And then again, my height here is 4. So 2 times 2 times 4 equals my target of 16. If my height is 2, then my base area has to be 8, because 8 times 2 equals 16. So let's come over here, and we know again, we can always multiply that number times 1. 1 times 8 times 2 is 16, but we can also say that 2 times 4 is 8. We multiply that by 2 to get 16. There's no other multiples of 8, so this is how we're set there. And then of course, if my height is 1, my base area is 16, and this one's going to give us like the most options, right? Because we can do 1 times 16 equals 16 times 1 is 16. We could say that 2 times 8 equals 16 times 1 is 16. And we, of course, can say that 4 times 4 is 16 times 1 equals 16, right? So we've kind of laid this out, right? So that these are my 3 rectangular prisms that have a base area of 16. These 2 have a base area of 8. These 2 have a base area of 4. And then, of course, up here, right, we only came up with one that gave us a base area of 2 and one that gave us a base area of 1. So that is a list of all of our potential rectangular prisms, flower boxes that would hold 16 cubic feet of soil. So let's go through and count them up. We have 1, 2, 3, 4, 5, 6, 7, 8, and I think there's one more hiding up here. Yep, and a 9th one, right? So going back to our question, how many flower boxes, all with whole number dimensions and a different size base, hold exactly 16 cubic feet of soil? And the answer here is 9 different flower boxes. So one final step in this might be to just go through and make sure we've checked all of these constraints, right? Like, did all of the volumes equal 16? Yes. Did we only use whole numbers? Yes. Did we make sure that we had different size bases? Yes. So I feel pretty confident in saying that there are 9 different flower boxes. Let's take a look at another one that's very similar but slightly different. Okay, so this one says that Mr. Price makes cakes for special occasions. His most popular size cakes have a volume of 360 cubic inches. The cakes have a height and thickness of 3 inches. Gosh, that seems pretty important. And all have different whole number lengths and widths. So again, no like fractions or decimals. No cakes have a length or width of 1 inch, right? So we can't use these for any of our side lengths. How many different cakes, each with a different size base, have a volume of 360 cubic inches? So this one, we actually like get off a little bit easier, right? Because if our volume is 360, right? And we are saying that our length times width, right? That's our base area, times our height. Well, it told us our height, right? Remember it said that right here that our height is 3 inches. So the base area is set, right? Because we are going to divide 360 by 3 to find our base area. So let's do that really quick. 360 divided by 3, that goes in once. It goes into 6 twice. And then it goes into 0, 0 times. So we have to make sure to put that placeholder up there. Right, so that means that our base area has to be 120 square inches. So when we look at our formula, right, we have 360, that's our volume, is going to equal 120 times 3, right? But we need to factor 120 out so that we can find all of our possible lengths and widths. We're going to do that on another page really quick. Same idea as earlier. We have 120. Well, we can start with 1 times 120. We can start with 2 times 60. We get 3 times 40. We get 4 times 30. 5 goes into 120. I think it's 18 times, right? Because 5 times 8 is 40, and 5 times 10 is 50, and 50 plus 40. Ooh, that's not right. That's only 90. No, it's 28. 24 times. Sorry. 24 times. We all make mistakes, right? So we get 5 times 24, 6 times 20. We end up with a whole lot of factors here, right? 7 does not equally go in to 120. 8, let's double check it really quick. See, 8 goes into 12 once. That leaves me with 40, right? So that is 15. 8 times, let's bring it down here so we don't get too confused, it's 15. Let's see, 9. Will 9 go in? So 9 goes into 12 one time. That leaves us with 30. So nope, 9 won't work. And then of course, hopefully we recognize that 10 will go in because it ends in a 0. And 10 times 12 and 11 doesn't work either. So these are all of our factors of 120. So when he's building his cakes, right, we could have a 1 by 120 by 3. Remember, our height was defined in our problem as being 3. So that's always going to stay the same. We could have a 2 by 60 by 3. We could have a 4 by, a 3 by 40 by 3, a 4 by 30 by 3, a 5 by 24 by 3, a 6 by 20 by 3. Let's see, we could have an 8 by 15 by 3, and a 10 by 12 by 3. So these are all of the possible cakes that we could create that have this volume. So let's go back and make sure that we've got everything correct here, right? So when I come back here, so cakes have a height of 3 inches. I made sure to take care of that. I have whole number lengths. I don't have any fractions or decimals. And then it says no cakes have a length or width of 1 or 2 inches, which means that I have 2 cakes on my list here that don't qualify, right? Because this one has a length of 1 inch and this one has a length of 2. So both of these are eliminated. I'm left with 1, 2, 3, 4, 5, 6 possible cakes. So how many of Mr. Price's cakes can he make that have a volume of 360 cubic inches, a height of 3 inches, and all of that good stuff? And the answer is we can make 6 different cakes. Okay, one more, and then I think that we're going to wrap up this lesson. Here, what if the 360 cubic inch cakes are 4 inches thick and any whole number length and width are possible, right? So basically we're doing the exact same problem, except for instead of it being 3 inches, now they are all 4 inches, right? So our height equals 4 inches. And we can include those 1 and 2 inch side lengths. So we're going to start off the same way. We're going to take 360 and we're going to divide by 4. Well, it goes into that 90 times, right? And so then we're just going to factor out 90. And we could have a 1 by 90. We could have a 2 by 45. We could have a 3 by 30. See, 4 doesn't go in. 5 does, though. 5 would be 18. 6 is going to work because it's a multiple of both 2 and 3, and that's going to be 15. 7 is not going to work. 8 is not going to work. 9 is obviously going to work, and then 9 by 10. And again, like we said earlier, right? Like when we get to the point where there are no numbers in between our two end numbers, then we are done, right? And like let's say that 9 didn't work. We just kept working from 6. We got 6, 7, 8, 9, 10, 11, 12. Eventually we would run into this 15, and that would have been where we stopped. But of course 90 is 9 times 10, and so we are done. So for this one, we can make 1 by 90 by 4, 2 by 45 by 4, 3 by 30 by 4, 5 by 18 by 4, 6 by 15 by 4, and 9 by 10 by 4, right? And again, remember, we got rid of that constraint about using not using 1 and 2 inch side links. And so here we have 1, 2, 3, 4, 5, and 6. So even though we changed some of the dimensions, we can still only make 6 cakes. As we keep reading, though, there's a second part to this problem, right? Like how many different cakes could be made? We answered that. Suppose that the cost of a cake that size is $25 plus $1.99 for every 4 cubic inches. So to solve this part of it, right, our base cost is $25. And then to that, we're going to add $1.99 times, well, for every 4 cubic inches. We pretty much already solved that, right? Because we already know that it's 360 cubic inches total. And we have already divided that number by 4. We did it for a different reason, but it's going to give us the same answer, right? We're going to get 94 cubic inch sections out of the cake. So we would multiply 199 times 90, and then that's how we would solve this problem. I would simplify this in real life to say that $1.99 is basically $2, and 2 times 90 is 180. and to that I would add 25. Now, because we can't just simplify it, though, we do need to account for the fact that it's not $2, it's $1.99, which means that at the end of the day, right, we're going to subtract from this 90 cents, right, because we just rounded up by 1 penny. So instead of it being 180 plus 25, it would be 179 and 10 cents plus 25, right? So the 10 cents part's not going to change because we don't have any other decimals. 9 plus 5 is 14. 7 plus 1 plus 2 is 10, right? I'm sorry, not that part. 1 plus 1 is 2. So the total cost of any of these cakes would be $204.10. Now, I know I said we were only going to look at one other problem, but I just want to make sure that we take a look at one more thing so we don't get stuck in this idea of doing everything the exact same way, and then it changes and we don't know what to do. Here it says Ray wants to buy the larger of two aquariums. One aquarium has a base that is 20 by 20 and a height that is 18, right? So one of his is a 20 by 20 by 18. The other aquarium has a base that is 40 by 12 and a height that is 12. Which aquarium has a greater volume? Right, so when we look at this one, we don't have to find any of those dimensions. We don't have to find any like different shapes. All we need to do is calculate out the volume of this one and the volume of this one, and then we compare them by subtracting. One final one, right? Again, here, John is making a chest that will have a volume of 1,200 cubic inches. The length is 20 inches and the width is 12 inches. How many inches tall will his chest be? Right, so in this case, right, again, we're not needing to factor numbers. We're not needing to do any of that. All we need to do is figure out how tall it will be. Well, we know that volume is 1,200. We know that the length is 20, the width is 12, and we need to find the height, right? So 20 times 12 is, well, 12 times 2 is 24, and times 10 is 240, times the height. So we would take 1,200 and we would divide by 240. Here we can ignore a 0 on the end of each of these. And we would figure out that this is going to go in, what is it going to be, like 5 times? 5 times 4 is 20. 5 times 2 is 10 plus 2 is 12, right? So the height of our chest that he's making is going to be 5 inches tall, right? So just make sure as you read the problem, you take a look at it and you figure out the best way to solve it. Start by identifying that question. What do you need to find? Then take your important information and make a plan. This is a tough lesson, so if you have questions, let me know. And of course, good luck.